Hello. Today another important topic, very important topic with related to theory of computation is non-deterministic finite automata. Is also called as a NDFSM or finite automata NFA. Let us understand what is the definition. In this video series, we will understand what is the definition of NDFSM, how it behaves like better than DFA, how do you define the NFA, and how do you construct NFA for the given language, and also will be demonstrating some of the examples. Let us see now what is a simple NFA. NDFSM can be expressed in simple automata that extremely complex in NDFSM. That means whatever the string you are express or need to construct for DFSM, it is little complex as compared to NDFSM. NDFSM is very easy for any complex problems as compared to DFSM. So, in order to overcome this complexity, reason is that NDFSM can also accepted by DFSM. That means before constructing a DFSM, first you have to construct a NDFSM, then you can convert back to DFSM. Reason is that it is accepted by DFSM. NDFSM, as I told, it is a very easier to construct any complex languages or complex strings. Is a useful concept for proving theorems and also play important role in theory of computation and also in theory of languages. NDFSM or NFA model, which allows zero transition, one transition, more transition on the same input symbol. This model is called NDFSM. I will repeat again. NFA model which allows the zero transition or one transition or more transition state on the same input symbol. This kind of model is called as NFA or NDFSM. Now, you'll understand the definition of NDFSM. Again, NDFSM also represented by M and defined by 5 notations as you like DFA. Right? So, all this notation is similar to DFA? No. The Q, sigma and Q naught, F is similar to DFA except transition function. Let us see what is capital Q, a set of states, nothing but Q naught, Q1, Q2. Then you already know what is sigma. Sigma is an input alphabet, that is nothing but A comma B. That means, as you told, it is a empty string, is not part of input alphabet. That means it is not a member of input alphabets. Then, what is a transition function? Here it is, as you told, transition function is differ in DFA. In DFA, Q cross sigma to Q, but whereas in transition function with respect to NDFSM, Q cross sigma to for Q. This is the main difference, technical difference with DFA. The rest of the notation remains same, that is Q naught is the initial state and F is the accepting state. The only one notation is defer, that is transition function with respect to DFA. The rest of the notation remains same, which is defined by 4 tuples Q sigma delta Q naught F. So this you have to give the definition in any of the exam. Okay. Let us understand this thoroughly through some of the example. Right, transition function delta, that means delta of q comma x. So it lead the obtaining q1, q2, etc. qk. That means there is on same input, it may go to the different state. Delta of q comma x, it may go to q1, it may go to q2, q3 and so on qk. So that this kind of transition is not possible in DFA. That means the resulting states with following one transition with symbol x. I will be summarizing this slide. The NFA can have a multiple transition on same input symbol. That means q of x, it may go to q1, q2, q3, etc. But whereas in DFA have only one transition on every input. There is no multiple transition. That's the difference between DFA and NFA. Let us understand clearly the concept of NDFSM can explain through the transition diagram. Right? Let us take input alphabet A. That means look at that q naught on A, it may go to q1, it also go to q3. Q naught on A, it go to q1 as well as q3. That means on same input, it may go to the two different states. Let us understand this. Two choices are there. With respect to this choice, the machine get confused. Before taking any decision, machine, it has to trace a two path. The choice number 1, there is q naught on A go to q1 and q2. Then onwards there is no transition. So then you have to take the decision. Still it is hold it is decision, and also it will come back on q naught, and on A it will go to the q3. There is no transition after q3 state. That means there are two paths are there. Before concluding it, it has to take the decision. Either two A's are there, then it landed in final state, then you can say it is accepted. If we have only one A, it will go to reach to the q3, there is no transition, then you can say reject. Try to understanding taking some example. On A, q naught on A, it go to the q, we have a input A, two A's are there. First input is read it, and second A also read it, will go to q2. You say all input is consumed, input buffer is become empty. At the same time it reached the final state. Then you can say it is accepted. Again you can trace it from the start state. So it will read 1A, reach to the q3. There is no transition then onwards. It should be in the q3 state, but at the same time input buffer cannot be empty. It has some input, still it is not empty. So machine, it can take the decision, the given string is not accepted, it is a reject. The overall conclusion is that if there is a computation of NFA that accept the string, that means all the input string is processed and the automata is in accepting state, then you can say accepting. Take one of the example, AA is accepted by NFA. Yes, absolutely, we have seen in the previous slide, which accepted since there are two A's in the input buffer, all the A's are process it, and reach the final state, then you can say accept it. Other example, because this computation is accepts. In other choice, it accept only 1A, it read it 1A and reach the Q3. There onwards there is no transition at all. By reading second A, then it will be halted there itself, and at the same time input buffer is not empty. Then you can say reject. This computation is ignored. Let us take another example on rejection example. We have 1A. It will read it 1A, reached the Q1, but there is no input in the input buffer. At the moment you are in Q1, Q1 cannot be a accepting state or final state, still it is rejected. At the second choice, again it will test machine, one more choice is there, that means one more path is there. While reading single A, reach the Q3, then there is no A in input buffer, but in the transition diagram, you are at Q3. Q3 is not a final state or a accepting state, then you can reject it. In either of the case, either it is in the rejecting state, even input buffer is empty, it will be rejected. Okay. Now this is one more example on rejection. On 3A's, we'll read all the 2A's. It's possible to read 2A's, but input buffer is not empty, but you are reached to the final state. Still it is one more input is there in the input buffer. Even though you are in the input final state, it is not accepting it. Automata will be in alt states. Right? It will reject it. Take one more choice, second choice, 1A, and reach to the Q3. You are at the intermediate state or it is a rejecting state, but input buffer is not empty. You are in rejecting state, still it is also rejecting it. These are the possible combination. So you try to understand when it is machine is accepted, when it is not accepted. That means there are two cases I have given it. All possible cases I have explained through the animation. Please try to read it. Please pause the video, listen it again and again. Try to understand when the machine is accepted. Okay, then let's move to the next topic is the overall summary of the previous two slides. An NFA reject a string. That means if there is no computation of NFA that accept the string. Okay, there are two cases here. For each computation, all the input is consumed and the automata is in non-final state, also rejecting state. Or input cannot be consumed, still it is also not accepted. So these are all rejected. All possible computation lead to the rejection. As you have seen in the previous slide, similar one I concluding it here. Try to understand this. Even when A is there, your input is become empty, but you are not in final state, is rejecting it. In the second case, even if you are go to the second path, you are at the intermediate state and input is become empty, still is not accepted. Okay, it says reject. Another case is again all your input is not empty, but you are reached to the final state, still it is not reject. Still it is reject. Sorry. In other path is as well, input is not empty, but at the same time you are at the intermediate state, still it is rejected. All possible computation, which are all it is rejecting choice. I hope you understand this NFA thoroughly through this multiple example. Now we will see some of the example how to construct the NFA. Some of the question will be like this. obtain an NFA to accept the following language L is equal to W such that W is belong to AB n power n or A power n A power n where n is greater than equal to 0. How do you construct it? As you told, try to understand the behavior of NFA and what are the transition will accept it. So then it is easy for you to construct. There are two cases are there. W have two string ABN or ABAN. So try to construct the machine, either it is accepting ABN or ABAN. First we will take ABN, which you can write it like this. I will start with the Q0. On A, there is a first input is A. While reading A, reach to the Q1. Next input is B. Taking B and go to the Q2. Next input is A. Taking A and reach to the Q3. This B, n is greater than equal to 0. That means it may be 0. Only it is B is absent. If it is n is equal to 0, B get absent, disappear. Given input is only A, B, A. In that case is accepted. Suppose A, B, that is also it is accepted. B can be, last B can be, appears 0 times and n number of times. 0 to n times. So it can comes ended with any number of times. In other string ABAN, machine also accept, either accept first string or second string. It is also very easier, right? There is a input AB, A power n, where n is greater than equal to 0 is shown below. Which accept first, it will take the first input from the starting state, it will reach to the Q1. Again there is input buffer B, input buffer having a first letter, it is B. It will taking a B, go to the Q2. In that term also AB is accepted since n is greater than equal to 0. A power n is 0, that means it will become epsilon, only this is AB. Right? Suppose if n is equal to 1, ABA will come, ABA will come. So A can be, last A can be, it can appear 0 to n number of times. So this will be accepted. Now the machine NFA can accept this string, first string or second string. How to join? These are the two multiple initial states are there. So, and also I will emphasize one more point is, remember it. So there is any finite automata can have a multiple final state, but it can have only one initial state. Any automata can have multiple final state, more than one final state. Okay, here it can have a two final state. I need to combine either accept or ABN or ABAN. How to combine this? Machine accept either ABN or A power n, where n is greater than equal to 0. Look at this. I will make like this. I will introduce a one more final state, initial state. I will EQ this Q0 and this Q0 become a intermediate state. Then what is the transition between Q0 to Q0? Here to here, there is an epsilon transition. Empty string. Where there is no input, you can use the epsilon. You can change the state from one state to other state over the epsilon. That's the beauty of epsilon. Empty string is represented epsilon. Even your machine can take a input. You can change the state from one state to another state over epsilon. This is not possible in DFA. This is possible only in NFA. So that's a more significant. NFA is very easier to construct as compared to DFA. So we'll see some more example as possible. Here all you can important. You can see these are the example in many of the exam. They may ask like this. There are two cases will be like this. The example is That means use of epsilon transition, multiple sublanguages. The L is equal to W belong to A comma B star, right? Such that W can accept A, B, A, or length of the W is even. Length of the W is even. That means either it is accept A, B, A, and length of the W is even, right? So now first try to construct NFA for A, B. So take this, as you told, you can use the epsilon transition. I have used it. So A, B, A, which accept A, B, A. The other case is also possible. It should be accept as per this problem statement. Length of the W is even. That means it can accept any string. That string length should be even. You can take A. You can take B, A, or B, A. So finally it will be reached to the final state. It can start with epsilon. Once it can come Q pi. Any given string having its length is even, irrespective of the any combination of input alphabets A or B which accept that even. So this will be the final NFA transition diagram. Another one, there is a pattern matching. How do you matching the pattern? The pattern will be like this. So L is equal to W. W has some combination as given here. W is A comma B comma C. The pattern has A, B, C input alphabets. The star. There exists X comma Y belong to A, B, C. X comma Y comma belong to A comma B comma C. So X and Y also it is the combination of A, B, C. It may appear 0 times or more times. So star indicate, already you know it. It is star indicate, it may appear 0 number of times or more times. So that means it can appear 0, 1, 2, 3, any number of times of A, B, C. Right? A can be appear 0 times, 1 time, 2 times and so on. Even C, it can be extended for B, C as well. Right? So let us see what is the combination of pattern as given here. W is equal to X, AB, CA, BB, Y. How do you construct it? First you try to construct for AB, CA, BB. Let us have constructed already. Look at this. AB, that is a middle string, substring AB, CA, BB. So this has come in a stretch. All the string is concatenated. AB will read it from the starting state. It read A, reach Q1. From B, from Q1 reading B, reach Q2, from Q2 reading C, reach Q3, from Q3 reading A, reach Q4, from Q4 can again read B and so on reach to the final state, then it will accept it. Then even Y, this is X and Y, it can be absent sometime, it can accept A, B, C, A, B, B because it is a star indicating. It can appear 0 times. But at the same time, X followed by this combination followed by Y combination. X can be any combination of A, B, C. It can rotate it in beginning itself. Need not to worry because multiple transition is possible. Look at the Q0 on A, it may go to Q0 as well as Q1. Right? It can possible. So it can rotate it here itself on the loop because n number of times X can appear or it may be 0 times. So A, B, C. Similarly for Y also at the end. Okay. But how do you know when take the transition to Q1 strategically? First time it can take it on first A. Second time it can take on second A and so on until A's are exhausted or you accept the string. So I think hope you understand this concept. Move to the next example is multiple keywords. The multiple keywords are like this. W is belong to A comma B star. then exist x comma y belong to AB, which is more or less similar to the previous problem. There are multiple keywords as given here. That first W is as this, either accept this string or accept BA will accept, which is similar one. This will be the first string combination, second combination will be this part. Okay. So first part it will always start with the A. It will start A, B, B, A. X could be A comma B and Y could be A comma B. Second string it can start with B, B, A. But it can X could be either this X could be possible in either of the cases. Then Y is as 2 final state in this case. So have to indicate 2 final state. Only one initial state is there. This way you can construct NFAs for this, right? But similar transition, similar problem could you construct for DFA is very difficult. So first you construct NFA, then you can convert back to. So checking from the end, right? Look at this. There is another example. L is equal to W belong to A comma B star. The fourth to the last character is A. Fourth to the last character is A. That means this last character is A. So fourth to the last character is A. First you have to construct A, first A, second A, third A, fourth A. It will accept it. Okay. Then any combination it can come last fourth to the last character. If you counting from the last to the end, from the end this side, the fourth character should be A. Fourth character should be A. Okay. So this is very important. So this it can achieved using this transition diagram. So another best example here, construct an NDFSM which accept any binary string that contains 0 0 or 1 1 as a substring. So that means it is a input alphabet is a 0 0 or 1 1 as a substring, which just you have to construct a NFA or NDFSM. So look at this. Either case is starting with a that is a state name, it is an initial state. On 0 0 it can accept 0 0 followed by any combination. So that means either accept 0 0 or not either 0 0 as a substring or 1 1 as a substring. In some cases 0 0 as a substring followed by any combination. Before also there is, it can be start with any zeros and ones beginning followed by substring 0 0 and ended with any combination of 0 and 1. So it is accepting it. Or your string as substring 1 1, it can start with any combination followed by substring 1 1 and ended with 0 comma 1, right? Any combination. Like this you can do n number of problems. I have limited here. So look at that another example. So NFA that accept all binary string that end with 1 0 1. Look at this. So any string if you take it, it can end with 1 0 1. 1 0 1. If we take any string here, it can end with 1 0 1. So first it is 1 0, minimum string is 1 0 1 1 0 1. A on starting with A. So accepting 1 will reach the B, B on 0 it will reach C, C on 1 reach to the D, then it is accepted. But it is ending it. Prior to this, that means beginning of the any string, it should be any combination of zeros and ones. Need not to worry about this. Anyway, it is a string is ending with 1 0 1, it is accepted. In other case, A star plus AB star. If that plus is indicate here, it is a union. It is even plus can be used or can use pipe can be used or union also you can use. Either accept plus indicate either accept A star or AB star or even pipe could be as. These are the operator you can use for the union operators. Okay, so these are the three operator. Don't get confused. These two can use it for any case. Suppose here the first case A star, either accept A star, starting with, suppose both the cases are epsilon. In the both the cases are epsilon, because A star plus B star, both our input is epsilon. In case it will be in the same state, you will be in the same state in the beginning itself. Initial and final state it will be in the beginning itself. Suppose here A, only A, input is A, so it takes A, reach the final state, and any combination of any number of A's it can come, it will take it and prove the first part. Other case, it can accept A, B star, it can A, B, A, B, A. So this will be the second part. This also will accept it. Okay, so this way can be construct